Hello, welcome to my tutorial video on basic geometric concepts. So we are going to look into angles on parallel lines, angles in a polygon, special triangles, special quadrilaterals, shapes and symmetry, and lastly rotational symmetry. So firstly, we'll need to understand what angles are. So basically, an angle is the measure of space between two intersecting lines. And then an angle is measured in degrees, and it is given by this symbol. That's the degree symbol. And then the maximum angle that can be recorded is 360 degrees. And this is a complete revolution, which can be represented by this diagram. And then half of this angle as a straight line, and this is 180 degrees. So this angle is half of a revolution, and it is 180 degrees. And then a right angle is an angle with 90 degrees, as shown on this. And then an angle that is less than 90 degrees is called an acute angle. So if you to look at this, this is the 90 degrees angle. And for example, in this instance, we have 55 degrees. 55 degrees is an angle which is less than the 90 degrees. So we could get 40 degrees, we could measure 30 degrees, we could measure even less, 10, 20 degrees. It's still an acute angle. And then an obtuse angle is an angle that is greater than 90 degrees but less than 180 degrees. So in this instance, this is the 90 degree mark. So our angle recorded in this instance is 120 degrees. So it is greater than the 90 degrees angle here. So which means that we could record an angle which is 150 degrees or an angle which is 170 degrees. All those angles are obtuse angles, so long they're less than 180 degrees. Okay. So a reflex angle is an angle that is more than 180 degrees but less than 360 degrees. So in this case, this is the 180 degree mark. And in this instance, our angle is 210 degrees. It is greater than 180 degrees but less than 360 degrees, because 360 degrees is a complete revolution, like we noticed in this instance. So which means that a reflex angle can be anything that is greater than 180 degrees. So we can have 207, we can have 190, we can have 270 degrees here. All those reflex angles. So now we'll look into angles on parallel lines. So firstly, we need to understand what parallel means. So parallel means that two lines are always the same distance away from each other, and therefore they will never meet. And so for example here, those blue lines, they are parallel lines because no matter how far you draw them, these lines will never meet. They'll always be parallel to each other. And then a line that cuts this pair of lines is called a transversal. So this red line here is what we call a transversal. So now the first set of angles that we are going to look at are called corresponding angles. So if you're given a set of parallel lines like this one, right, and then the transversal cuts the parallel lines, right, so the angles that are formed here, like for example the angle F and E, they are equal, and sometimes they are called F angles because if you're to look at them, they kind of form an F shape. This is kind of an F, so sometimes they are called F angles. Okay, so you should notice that F and E are equal, so generally corresponding angles are equal. So these diagrams here, they give examples of corresponding angles. The next set of angles that we're going to look at are alternate angles. So again, if you were to look at this diagram, the angle D and C are what forms the alternate angles, and you should also note that alternate angles are equal. So they are sometimes called Z angles. Why? Because if you're to look at them, they kind of form a Z shape here. So that's why they are called Z angles. So again, these diagrams, they give examples of alternate angles that can be formed on parallel lines. And then the next set of angles that you're going to look at is vertically aligned angles. So vertically aligned angles are equal. That is a point that you should take note of. So for example, given this set of parallel lines, A and B, they form vertically opposite angles. So sometimes they call vertically opposite angles because if you're to look at them, they are actually opposite. Okay, so these diagrams, they give examples of vertically aligned angles that can be formed on parallel lines. And then another set of angles that can be formed on parallel lines is co-interior or allied angles. So those ones, they're angles on parallel lines, and they add up to 180. So for example, their characteristic feature is that if you to look at H and G, if you add up G and H, they should give you 180 degrees. So this is how they're represented on parallel lines. For example, H and G. And also take note that they have two names. Either you call them allied angles or interior angles. So don't be confused. If you see on your exam paper, you'd ask it to find allied angles, know that they're also interior angles. So don't be confused between the two names. And these are also diagrams that show examples of allied angles on parallel lines. So the next set of angles that we are going to look at are alternate exterior angles. So you should know that alternate exterior angles are equal. So for example, in the diagram that is shown on the screen, angle D is equal to angle A, and they are alternate because if you're to carefully look at them, angle A is on the opposite side of angle D, so is angle C on the opposite side of angle B, right? So these are what we call alternate exterior angles. And then now we are going to look at an example that will encompass all the types of angles that we have looked at that can be found on parallel lines. So the example reads, CF and GI are parallel lines. Find the angle marked X in the picture below, and then state which angle rule you use at each step. So you might as well need to pause the video, look at the question, go through it, and try to find the value of X. Okay. So firstly, we know that the angle BEF, which is this one, this is the angle BEF, right? And EHJ, this is EHJ. We know that these are corresponding angles, and from what we learned that corresponding angles are equal. So this means that the angle EHJ is 39 degrees, right? And then we also know that the angle EDH and DHG are alternate angles. So this is the angle EDH, this is the angle EDH, and the angle DHG. So this is the angle DHG, this one. We know that these are alternate angles, and from what we learned that alternate angles are equal. So this implies that these two angles are equal to 76 degrees, and we can conclude that DHG is equal to 76 degrees, which is this angle. And then now we know that the angle DHG, this angle, this one, and the angle DHE, which is this angle in the middle, and the angle EHG, which is this last angle, they are angles on a straight line. So we know that the angles on a straight line, they add up to 180 degrees. So since we know that they add up to 180 degrees, we can then calculate the angle in the middle, and we calculate it by saying DHE is equals to 180 degrees minus the two known angles, which are 76 degrees and 39 degrees. So we get 65 degrees to be the angle in the middle, which is here shown on the diagram. So now from what we learned about vertically opposite angles, and we say that vertically opposite angles are equal. So to find the angle x, we see that it is vertically opposite to the angle DHG that we just found. So we can safely conclude that angle x is equals to 65 degrees. So thank you for watching the video. I hope you're able to get the solution to this example. If not, please kindly go through it until you've gotten the gist of it. See you in the next video.